welcome to the deep dive.
Hmm.
So, I want you to picture something for a second. Have you ever been scrolling online and, you see a project?
Oh, yeah, like a DIY home renovation or something.
Right, exactly. Or maybe it's this intricate baked good or a beautiful backyard gardening setup,
Yeah.
and it looks absolutely flawless.
Oh, always. Flawless lighting, perfect angles.
Exactly. So you get inspired, you go out, you buy the materials, you meticulously follow the steps, you put in all this hours of sweat equity. And then you step back to look at your final result, and it looks, well, a little underwhelming.
A little scraggly.
Yeah, scraggly is the perfect word for it. The expectation in your head just clashes so hard with the reality sitting right in front of you.
It is honestly a universally frustrating experience. I mean, the final product just refuses to match that glossy, filtered picture that motivated you in the first place.
And that very human experience, that disappointment, is exactly where we're starting today. We are unpacking a really fascinating personal journal entry. It's dated May 28th, 2026, written by someone named Ang.
Yeah.
And the entry is titled, Notes on Gardening Part 908, Reflecting on My Sesame Plant Seed Germination Trials.
The scientific name for that being Sesamum indicum, so just your standard sesame plant.
Right. Now, you might be wondering why we are dedicating an entire deep dive to someone's personal, gardening notes about sesame seeds.
Which is a fair question.
It is. But our mission today is to dig into these notes because they represent so much more than just agricultural trial and error. This short diary entry, it honestly operates as a masterclass in the scientific method.
Oh, absolutely.
It's this brilliant look at rapid prototyping, and most importantly, it explores how to diagnose and adjust your environment so that you don't just survive, but you actually thrive. Okay, let's unpack this.
Let's do it.
So Ang sets up this perfect tension between what we can call basically Instagram versus reality. We were dropping in at the end of Ang's first major experiment with these sesame seeds.
Right, the first run.
Yeah. And we need to understand the outcome of that initial run before we look at the adjustments they made. So Ang actually successfully grew these sesame plants from seed. They reached full maturity, they bloomed, they even produced seeds.
Right, so life was created and sustained. A full, uninterrupted life cycle was completed right there in the dirt.
Exactly. But Ang writes this entry and notes that the foliage of the plant, the leaves, were, quote, thin and sparse. It completely lacked that lush, beautiful, vibrant look of the sesame plants that Ang had originally seen online.
The ones they wanted to replicate.
Right. The aesthetic reality was a major letdown.
You know what's fascinating here is the underlying definition of success, right? It's really worth looking at. Because from a purely botanical standpoint, I mean, from the perspective of the sesame plant's own biological imperatives, this experiment was a massive, unmitigated triumph.
Wait, really? A triumph?
Oh, yeah. Think about it. A plant has a finite amount of energy to spend, right? Its ultimate goal is just to secure the next generation.
Okay, I see where you're going.
Yeah, so it survived the germination process, it matured, it used its energy to bloom, and it successfully reproduced by manufacturing new seeds. In the wild, an organism that manages to reproduce, well, it basically wins the evolutionary gold medal. It did the job it was programmed to do.
Okay, fair point. But, if the plant successfully reproduced and it literally handed Ang a whole new generation of seeds, did it actually fail?
That's the big question.
Right. I mean, it seems like Ang might be acting as a really harsh critic of a perfectly functional, albeit kind of ugly, plant. Shouldn't function over form count for something here?
Well, the distinction really comes down to the purpose of the cultivation itself. Like, if Ang were a subsistence farmer whose singular goal was to just harvest sesame seeds for food or maybe to press them for oil, the sparse foliage might just be a minor footnote.
Right, like who cares what the leaves look like if you're getting the oil?
Exactly. Or, maybe just a slight indicator of environmental stress. But Ang is clearly aiming for a specific qualitative standard here. They want the plant to reach its full phenotypic potential.
Okay, phenotypic potential. Let's break that down for the listener.
Sure. It basically means the absolute best physical expression of its DNA based on its environment. They don't want the plant to just, drag its battered leaves across the finish line of reproduction.
Right, limping over the finish line.
Yeah. They want it to look robust, healthy, and lush while doing it. It's the difference between merely surviving a marathon and finishing it with a personal best while barely breaking a sweat.
Okay, I love that analogy. So Ang recognizes that the plant is just surviving, it's not thriving. And instead of looking at this thin, sparse plant and just giving up or throwing the pots away or deciding, hey, I just lack a green thumb.
Which is what most of us would do.
Honestly, yes. But Ang starts diagnosing the gap between mere survival and actual flourishing.
Right. And the culprit identified in Ang's notes is a suboptimal microclimate.
A microclimate. Okay, so Ang writes that to get that lush, leafy look, these specific sesame plants require two distinct environmental factors. First, full sunlight, and second, adequate nitrogen.
Right. And the concept of a microclimate is so crucial to understand here. Because when we hear the word climate, we tend to think of the general weather patterns in a city or a region or like a hardiness zone on a map.
Yeah, like I live in a tropical climate.
Exactly. A microclimate, however, is hyperspecific. It is the exact localized set of conditions surrounding a specific plant, like down to the literal square inch of soil.
Wow, okay, that's specific.
Oh, yeah. It's factoring in whether the shadow of a nearby fence happens to fall on that exact spot at, say, 2 o'clock in the afternoon. Or it's measuring whether the soil in that specific 6-inch radius happens to be holding less water or fewer nutrients compared to the soil just 3 feet away.
So Eng is looking at the specific bottlenecks. Sunlight and nitrogen are the missing ingredients here. Let's break down the nitrogen part real quick because the notes mention it specifically for the foliage.
Right. So nitrogen is a fundamental building block of chlorophyll. And chlorophyll is the pigment that makes leaves green. And, well, more importantly, it allows the plant to absorb sunlight to create energy. Without adequate nitrogen, the plant literally lacks the raw materials required to build its own biological solar panels.
Biological solar panels, I like that.
Yeah, it cannot produce thick, lush leaves because it simply doesn't have the chemical inventory to construct them. In biology, there's this well-known principle that growth is dictated not by the total amount of resources available, but by the scarcest resource.
Okay. The weakest link in the chain.
Exactly. And Eng has pinpointed that sunlight and nitrogen are the specific limiting factors holding this poor sesame plant back from its lush potential.
So what does this all mean for us? Listening to this mechanism, it is honestly impossible not to see a massive parallel to human work environments or, just human life in general.
Oh, absolutely.
Because we can be placed in a suboptimal environment, right? A toxic job, a cramped apartment, a stressful relationship dynamic, and we can technically still produce seeds.
Right, you still get up and go to work.
Exactly. We hit our deadlines, we pay our bills, we fulfill our basic societal functions, but we are walking around with thin, sparse foliage. We're burnt out. We aren't lush. We aren't thriving at all.
Because we operate within our own complex microclimates. I mean, you might have the overarching climate of a good salary or a respected job title on paper.
Right.
But your hyper-local microclimate could be, say, a micromanaging boss or a complete lack of natural light in your workspace or just a grueling daily commute.
Yeah, the commute alone will get you.
Seriously. And if your daily environment is lacking the human equivalent of full sunlight and adequate nitrogen, so let's say psychological safety, creative autonomy, or even just restorative sleep, you are going to look and feel sparse.
Yeah.
You are meeting the minimum biological or professional imperative, sure, but you are not reaching your full phenotypic potential.
So Ang's diagnosis is this really great reminder that when things aren't looking quite right, we shouldn't necessarily blame the seed, right? We shouldn't just assume we're inherently flawed. We actually need to audit the microclimate. Once you identify the missing nitrogen, whatever that happens to be for you, you can start to alter the environment.
Exactly.
But here is where Eng's approach gets genuinely unconventional. Because you would think the logical next step is to just, go buy some nitrogen fertilizer and move the little pots to a sunnier window.
Right, fix the immediate problem.
Yeah. But instead, Eng makes a massive pivot and completely changes the parameters of the gardening strategy.
Yeah, Eng swaps out the experimental subjects entirely.
Which is wild.
Yeah.
Eng writes that sesame has officially replaced basil and celosia as their go-to plant for seed germination experiments.
Yeah.
And the reasoning provided is entirely data-driven. Honestly, it reads way more like a lab report than a garden diary.
Yeah, for sure.
Eng lists the reasons. Sesame seeds are assortable, they are highly available, they boast a very fast and high germination rate, and crucially, because they are annuals, Eng can observe their entire life cycle in a very short amount of time.
If we connect this to the bigger picture, this is the absolute essence of rapid iteration. Eng didn't just learn a lesson about the biology of sesame plants. Eng learned about the process of learning itself.
Oh, that's good. Process of learning.
Think about software developers. They release beta versions of applications to get data as quickly as possible so they can fix bugs and iterate. If you are a gardener trying to perfect your understanding of microclimates, and you are experimenting with a plant that takes, say, 2 years to mature.
Your feedback loop is agonizingly slow.
Yes, you make a tiny tweak to the soil composition, and you literally have to wait 24 months to see if it actually works.
That sounds miserable. So by abandoning the basil and the celosia and shifting all focus to sesame, Ang has aggressively tightened that feedback loop. An annual plant which completes its life from a seed to a mature plant to producing new seeds all in a single season, it's the biological equivalent of rapid prototyping.
A minimum viable product, basically.
Exactly. You input your variables, you get your visual data fast, and you can immediately iterate for the next batch. But here's where it gets really interesting, though.
Okay.
Reading that section of the notes, it forces you to question the ultimate goal of the person holding the trowel here. Is Ang actually a gardener trying to grow beautiful plants? Or is Ang a scientist who is basically just using dirt as a spreadsheet?
That is a great way to put it.
Right. It sounds like Ang cares way more about the velocity of the data than the actual aesthetic of the plant. They dumped basil and celosia, not because those plants are ugly or undesirable, but because they weren't yielding data fast enough. The backyard has literally become a laboratory.
At this level of systematic inquiry, the line between gardener and scientist completely blurs. I mean, Ang is optimizing for learning velocity. The sesame plant is no longer just a potential piece of decorative foliage, it is an instrument of measurement.
Right.
It's a biological sensor that Ang is deploying to test the physical environment. Approaching a hobby, which is often deeply subjective and emotional for people, with this level of clinical objectivity, it's a powerful paradigm shift.
And that objectivity shines through so clearly in the very next part of the journal. So now that Ang has the perfect experimental subject, the rapid prototyping sesame seed, and the diagnosis, which is the suboptimal microclimate lacking sun and nitrogen, we see the scientific method applied to the next step.
The second batch.
Yeah. Ang writes that based on the promising results of the first batch, and promising not because of the leaves, but because of the high germination and fast life cycle, they've already started the next batch of seeds.
No time wasted.
Exactly. Ang is taking this second batch outdoors. But they aren't just putting them all in the blazing sun. They are deliberately testing different microclimates outdoors, utilizing varying levels of full and partial sunlight to see if it yields that lush foliage they want.
You know, the emotional resilience in this approach is really striking. Notice what is entirely absent from the journal entry. There is no despair.
Right. No crying over bad leaves.
Exactly. There is no mourning the ugly first batch of plants. That first batch was completely stripped of its emotional weight and categorized simply as a baseline. It was just raw data.
Raw data.
And moving forward, Ang is systematically isolating variables. In casual problem solving, if a plant is sick, a normal person might change the soil, move it to a new window, water it twice as much, and add fertilizer all on the exact same day.
Guilty. I have absolutely done that.
Oh, we all have. But if the plant gets better, you have absolutely no idea which of those 4 interventions actually cured it. The data is muddied.
Because you've changed too much at once. It's like A/B testing a website, but with dirt and seeds.
Yes.
Like tech companies will show half their users a blue checkout button and half a red checkout button and just see who clicks more. Everything else on the page stays identical. So Ang is showing half the seeds full sun and half the seeds partial sun. But wait, let me make sure I'm mapping this logic correctly. Ang already deduced from batch 1 that the sesame requires full sunlight to thrive. By intentionally testing both full and partial sunlight in batch 2, isn't Ang actively risking another batch of sparse, ugly plants in that partial sun group?
Oh, Ang is absolutely risking another batch of sparse plants.
So why not just put every single seed in full sunlight, if that's what the research says they need? If the goal is lush plants, giving some of them partial sun feels like a step backwards.
Well, think about it.
Oh, wait, I think I get it. If Ang puts every single seed from batch 2 into full sunlight outdoors, and they all grow up to be lush and beautiful, Ang wouldn't actually know if it was the sun that fixed the problem.
Exactly. Because batch 2 is outdoors now, the entire overarching climate has changed from batch 1. The temperature outdoors is different, the ambient humidity is different, the natural soil biology and nitrogen levels might be completely different from the indoor pots.
Ah, okay. So by keeping a subset of the outdoor batch in partial sunlight, Ang is creating a control group.
A comparative tool, yeah.
Right. So if the full sun outdoor plants grow lush and the partial sun outdoor plants grow sparse, then Ang has definitively isolated and proven that the sunlight is the primary variable controlling the foliage.
Regardless of all those other new outdoor factors like humidity or temperature.
Wow.
Yes. Ang is willing to sacrifice a few plants to partial sunlight in order to gain absolute, unshakable certainty in the data. That willingness to endure a small, localized failure just to validate a larger hypothesis, that is the hallmark of a true experimenter.
They are paying a small tax in ugly plants to buy pure knowledge.
That's a great way to put it.
Bringing this all together for you, the listener. We started with a very short diary entry about some disappointing plant leaves, but it unfolds into a complete philosophy of how to approach problems. A garden isn't just a place to grow things. It's a laboratory for understanding environments.
Well, it really is.
And the core takeaway here is that we should be looking at our own lives, our projects, our hobbies, or even our careers through this exact same lens.
The big shift in mindset here is moving from I failed to I have established a baseline.
I love that.
Because once you have a baseline, the only logical next step is to adjust a single variable and run batch 2.
And we can apply this A/B testing methodology to our daily routines. Like, let's say you are constantly feeling groggy in the mornings, right?
Yeah.
Your foliage is sparse.
Right, you're burnt out.
Yeah. Don't just change your diet, your mattress, and your alarm clock all on the same day.
Right.
Run a sesame seed experiment. Test one variable. Try going to sleep 1 hour earlier for a week, keeping everything else exactly the same, and measure your energy levels. Then maybe the next week, go back to your normal bedtime, but try eliminating screens an hour before sleep.
Isolate those variables.
Isolate the variables.
Yeah.
Prototype your way to a better environment so you can gather data and iterate without waiting years for a result.
Exactly.
But before we wrap up this deep dive, I want to leave you with one final, slightly provocative thought to mull over based on Ang's journal.
Okay, let's hear it.
So we know Ang is starting this second batch outdoors with different sunlight levels, specifically to achieve that lush, beautiful, Instagram-worthy foliage that was missing in batch 1.
Right, the ultimate aesthetic goal.
But think back to what we established at the very beginning of the deep dive. That first, ugly, sparse batch already successfully produced seeds despite having terrible leaves.
Sure.
It achieved its core biological imperative in a suboptimal environment. So here's the question for you to consider. Is it possible that by finally creating the perfect, luxurious microclimate for beautiful leaves, Ang might actually trick the plant?
Oh, wow.
Right. By providing so much nitrogen and so much perfect sunlight, could the plant become so comfortable and so focused entirely on growing its lush, extravagant foliage that it gets lazy at the expense of producing any seeds at all?